Hello students, and welcome back to another math video, this time on fractions and unit rates. We already talked about unit rates, and basically it meant division. So these were all different ways that we figured out a unit rate, but in the end we basically were taking two numbers and dividing. And when we did that, we ended up with a value compared to 1 for a particular unit. When we get into fractions and unit rates, we're going to see something called complex fractions. What a complex fraction is it's a fraction inside a fraction. Whoa, check it out. Alright, here's our fraction, 2/3, but now I'm going to put it over 7. Well, we've talked about this fraction bar right here meaning a few things. It means division. Just like this one right here also means division. It means 2 divided by 3, 2 out of 3. This larger one would be 2/3 over 7, or 2/3 divided by 7. So to solve a complex fraction problem, we can write this out as 2/3 divided by 7, and I'll put 7 over 1 to make it like a fraction. And now we have to follow our rules for dividing fractions, which was to keep, change, and flip. So I'll keep my 2/3, change division to multiplication, flip this to be 1 over 7, and now we multiply straight across, and this is going to equal 2 over 21. Here's problem 3 from your homework. 8/9 over 6. It can be a little confusing because there are two horizontal lines, but you'll notice that this one is larger, so we want to keep this together as the fraction. And we want to read this to ourselves as 8/9 divided by 6. So let's set it up that way. 8/9 divided by 6. And we'll follow our rules for dividing fractions, and that is to keep, change, and flip, so that I have 8/9 times 1 over 6. I do see a little bit of cross reducing I could do here. They're both even, so I can divide them both by 2, which makes things a little simpler. And now I have 4 times 1 is 4, 9 times 3 is 27, and I'm done. You also see some problems in your homework where we have a fraction unit rate in a word problem. The key to solving these is to closely read the question. For example, in number 7, at the end, the question is, what was the cost per yard? That's really important. Cost per yard. Here's why it's important. We talked about per really meaning like division. So cost, that's always going to be in money. So I have cost per yard. So my final unit rate is going to be some amount of money, like, I don't know, $1 per yard. This helps when I go to set the problem up, because what I need to do is set my division up so that I have the money amount up here on the top divided by the yard amount. And then my final answer will be this, cost per yard. Let's do that one problem. So number 7 reads, Mary is making pillows for her life skills class. She bought 2.5 yards of fabric. Her total cost was $15. What was the cost per yard? Now, there are two different ways we could set this up. So here are the two ways. So which one is going to give us the answer that answers the question? So the question is cost per yard. Cost per yard. This is the one that follows that setup. It starts with the money, which is the cost, division next, which is our per, and then we have the yards. So we need to do $15 divided by 2.5 yards. So here we go, $15 divided by 2.5 yards. I'll write that as 15 over 1 divided by I'll turn this into a improper fraction. 2 times 2 is 4 plus 1 is 5 over 2. And if I keep, change, and flip, I'll have 15 over 1 times 2 over 5. If you see the cross reduce right here, go ahead and do it. If you didn't see it, that's okay. You can just reduce later on. 3 times 2 is 6 over 1. So now I need to answer the question. 6 over 1. So remember, cost per yard. So $6 per yard would be our final answer. So that's it, just a quick little one. Don't be scared by complex fractions. It's okay, we can have a fraction within a fraction. It's alright. Go ahead and give those a shot, watch the video a couple times, and we'll see you tomorrow.